Section 2.6 is transformations of functions. And I want to remind you that if you're ever asked to graph something, don't ever forget that you can plug in values for x, see what comes out as the output for y or f of x, and put that point on a graph. And that is how you can graph a function. So never forget that. But there are ways to maybe streamline the process or kind of confirm things by thinking about the idea of transformations. So the idea behind transformations is basically, if you have kind of one of those basic functions that we've already talked about, what can you do if that function has just been changed slightly by adding or subtracting a number, multiplying by a number. There's these different things that can happen to your basic functions that just kind of move the function around a little bit or change its shape a little bit. But just by being able to recognize what's happening to the function, it can give you a better idea of what that function should look like if you are being asked to graph it. So what we're going to be looking at is different transformations based on the function y equals x squared. So this, what you see there with the dotted lines is y equals x squared or f of x equals x squared, however you want to say it. Either one is fine, but that's what you're seeing there. So that's that basic function. And then we're going to be talking about how making modifications to that function changes it without having to come up with a whole bunch of x values, figure out what the y values are, so on and so forth, which can take a long time. So we're going to start with what you see here. We have two examples. One is taking your x squared and adding 1. The second one is taking your x squared and subtracting 3. So just to start off, I want you to think about the fact that, for example, when you plug in 0 to this new function, you're going to have 0 squared plus 1, and that's going to give you 1. So you no longer have 0, 0, now you have 0, 1. If we were to put in, for example, 1, you can see that we're going to have 1 squared, which is 1, plus 1, which is 2. So we're now going to have this point here. And then remember, I've talked a little bit about the fact that parabolas have symmetry, over the y-axis, or functions can, quadratics can, it depends on the situation. But in this case, they're symmetric over basically their vertex line. So anyway, so in this case, that is also happens to be the y-axis. So notice I have these 3 points already. And what I really want you to see is the fact that if you look at this point, and this point, the new points are all just a point that is a vertical shift 1 unit up. So if you can find any other point on this parabola and you just move it up 1, come over here, we have this point, we move it up 1, you will now have the new graph of this x squared plus 1. So it's simply taking any point on that graph, and I've picked some that are kind of the nicer points, but any point on that graph, and just shifting that point up 1 unit, a vertical shift. And that will create x squared plus 1. That's all you have to do. So I did choose a few points there just to show you that that's the pattern that's happening, but I do want you to see that that's all you'd have to do is just take those y values and shift them up 1. Similarly, when we have x squared minus 3, the only difference is now instead of adding 1, we're subtracting 3. So now that y value, any points you can find on this original parabola, are now going to be moved 3 units down. So if you want, you can pause and take a minute, see if you can find some points on this parabola, move that y value 3 values down, and then come back and see if you've got it. So I'm going to have down here, this point is going to go 1, 2, 3. This point over here, 1, 2, 3. Then over here, 1, 2, 3. Again, I'm picking points that are like going right through one of the values. 1, 2, 3. You could also think about the symmetry. And then we just connect them. So So you'll notice it's the same shape. We definitely have the same shape here. The only thing is that it's a vertical shift. So notice there's a note there at the bottom that I'm going to mention. And there we go. You know, so notice that it's saying if you have a function, so in this case that's the x squared, and then you have some value afterwards, some constant afterwards, it's just the original graph shifted p units vertically. So the big thing here is to understand that the shift is vertical, and if p is positive, it's going to shift up, and if p is negative, it's going to shift down. So that's the thing that you want to remember. Otherwise, everything else is the same. Okay, so take a look at this. Notice that there is a difference here. And the difference is that instead of putting some value on the outside of the x squared, so x squared plus something, x squared minus something, we now have the change happening inside before the square is happening. So before kind of that basic function thing is happening, the squared, that's our situation. So we'll take a look at the first one. So we have now x plus 1 quantity squared. So I'll do a couple points to kind of show you the pattern here. But now if I put in 0, notice when x is 0, we do get 1 for our y. When x is negative 1, notice when x is negative 1, if I put that in there, negative 1 plus 1 is 0, and then I'm going to square 0. So then I just get 0 coming out. I kind of already know what's happening here, so I'm going to pick negative 2. Notice when I pick negative 2, I add 1, which is a negative 1, and I square it, and I get 1. So now I'm here. So hopefully you can kind of see that we have the bottom part of this parabola, and it's shifted just a little bit to the left. Just a little bit to the left, specifically 1 unit, not surprisingly. And then if we put in negative 3, we'll have 4. And if we put in 2, we'll have, no, I'll put in 1, and then I'll also have 4. So what I want you to see that's happening here is all these points that we have on the original. So notice we have, what I've changed here is this point, this point, this point, this point, and this point. I want you to notice that what's happened here is the x value has changed. So the x value has changed, and it has shifted 1 to the left. So notice it's 1 to the left. And so now I can connect them, and I still have a parabola, and it's no different. Okay, so there's that. Now we're going to take a look at the bottom before we look at our next example. So notice in general it says if you take that basic function and you do something within it that adds or subtracts a value. So notice we have a minus p here. Notice the minus p. It's going to be a shift horizontally. But to be honest, it's the opposite. You have to think opposite. So students are going to say, oh, x plus 1 squared, I'm adding 1, x plus 1. But the way that this works, as you can see, because we plugged in some values there, is you want to actually look at it like this, x minus a negative 1 squared. So in this case, p is a negative 1, which means it's going to shift minus 1 or 1 to the left. And so that's what's happening. And again, we verified that using values. So in the other one, however, we have it in that form, x minus 2 quantity squared. So in this case, p is 2. So we're going to be translating 2 units horizontally to the right. So what I'd like you to do, if you can, is pause it and then see if you can move that 2 units to any point you can find, 2 units to the right. So that means the x value is what's changing, and moving 2 values to the right, and then put those points on and connect them. So I'm going to have here, this one is going to go 1, 2. This one is going to go 1, 2. I'm already kind of seeing it. Up here, 1, 2. Here, 1, 2. and then I just connect. I already know it needs to be that parabola shape, so I'm just making that happen. Okay, so really notice that big difference. So there is a big difference. I'll kind of just write something over here. There's a big difference between this is a shift up, and this, which is a shift, in this case, left. So there is a big difference between those two. You can always plug in some values, make sure that what you're doing does make sense. Don't forget that, but that's the idea. Vertical shift here, horizontal shift here. All right, now we got a little bit more here, a little bit more. Yep. All right, so now we have this idea of negatives. So it really kind of depends on what function you have. There's a general rule, but you'll see with the different functions kind of what that looks like. So notice that we have, in the first one, we have our x squared, and now a negative is just put in the front. Just a negative. So if I start with that, it's logically speaking just going to take every y value and make it negative. I can take every y value because I put the value in, I square it, and then I just multiply it by a -1. So all your y values are now going to become negative. So what that does is we have 0, 0, so we still have that. We have 1, 1, so now we're going to have 1, -1. We're going to have a -1, which now gives us a -1. And so you can see that any value up here is now just going to shift the same amount on the other side of the x-axis. So do notice that, because as you can see, that's what's happening. So I'm going to do that on the other side as well. So notice it's a reflection. Notice it's a reflection. And so it's the same exact thing, just a reflection. And we have that. So we've got a rule here. So down at the bottom in the note, notice it says the graph of y equals negative f of x. So that negative just being on the front of it is the graph of your original reflected about the x-axis. So it's doing that flip. I'm going to do that now on the other one. So here's the other one here. That's for x cubed. So I'm going to do that, and then I'll show the other one. So what I'm doing right now for both of them is this idea. So when you have the x cubed and you just put the negative in front of it, it's still going to do the same thing. So let me first, so that you have this, f of x equals negative x squared. And then over here, the same thing. So normally I'd have 1, now I'm going to have a -1. 2 would have given us 8, so now that's going to head way down here to like a -8, somewhere down here that I don't have. The 0, 0 is going to stay. Now my -1 gave me a -1 originally with x cubed, but now it's going to give me a +1, so it's going to change that y value. So I'm just reflecting all my points over the x-axis, and that's going to send me up here. And then I'm going to try to, draw something. I'm going to try that looks very similar, but as you can see, it is actually a flip over the x-axis. So here is our f of x equals negative x cubed. Okay, so flip over the x-axis. Now I'm going to change my color. I'll go to green. Now I'm going to do the other situation. So this is when, instead of just sticking the negative on the outside, you put it into wherever the x is and then do whatever the thing is. So in this case, you now have a negative x, and then you're taking it and you're squaring it. And so that's negative x times negative x, which, because this is an even function, just gives us x squared. And I'll be talking about even and odd functions soon, but this is the same as when we talked about symmetry. There's the idea of symmetry here. So we put in negative x, and out came x squared. So notice that that's just the original function. That's just the original function. But in terms of this definition here, what it actually is, so what I'm doing right now is I'm doing this one. So I'm putting in the negative x to both of these. It's a reflection about the y-axis. So it's just going to take it and it's going to flip it around the y-axis. Well, for x squared, because that's, you put in the negative x, you get the same thing. That is actually just a flip. So I'm taking this side becomes this side, it flips over the y-axis. This side becomes that side, flips over the y-axis. So it just ends up giving you the same thing that you started with, but all the sides, it's just gone to the other one. So this is basically f of x equals that negative x squared. It's a reflection over the y-axis. For the negative x cubed, or for the x cubed, now I'm going to put in a negative. Now I'm dealing with this situation. Understand that that is just what you get when you do negative x times negative x times negative x. And because it's cubed, that will give us still, and I'll write it up here because of space, negative x cubed, negative x cubed. But it is a reflection over the y-axis. Well, for this function that you see here, that just means that we're going to reflect it over the y-axis, Well, that's the same thing that happened when we did put the negative on the outside. So you can see that it really just depends on what function you have, but because one of these functions is even and one is odd, which again I'll talk about soon, that's the reason that they do kind of two different things, but also just the reflections in one case gave you the same thing, and in one case gave you the same thing either way. Again, that has to do because of the degrees of the polynomials. So just remember, the key thing here, I feel like I'm just using a lot of colors to just move stuff around here, but make a note that when you stick a negative on, it's going to be a reflection about the x-axis. When you put that negative inside your function, depending on, where am I? There I am. Depending on what you look like, what it looks like when you stick that negative x in, it's going to be a reflection about the y-axis. So negatives are reflections. That's really the key thing to remember here, make a note of. They are reflections over the different axes.